cetane and octane numbers. At the end of this lesson, you will be able to describe octane number, describe cetane number. Since the development of internal combustion engines, inventions have been made to improve their efficiency. One of the primary aspects of which is to develop the understanding of the relationship between the engine and fuel that burns within it. The octane rating is a measure of a fuel's ability to avoid knock. Knock occurs when fuel is prematurely ignited in the engine cylinder, which degrades efficiency and can be damaging to the engine. Scientists discovered that some fuels knocked more readily than others. Experimental studies led to the determination that of the standard fuels available at the time, the most extreme knock was produced by a fuel composed of pure normal heptane, while the least knock was produced by pure isooctane. This led to the development of octane scale for fuels. Similarly, cetane scale was developed for diesel fuels. Octane number. Octane number represents the knocking characteristics, especially for gasoline in IC engine. The quality of gasoline or petrol determines the octane number. When gasoline is burned in a spark ignition engine, it produces power. A good quality gasoline burns smoothly without making any noise in the engine. When we burn bad quality of gasoline, it produces a sudden high pressure and it is not smooth all the time. Thus, the pressure waves or knock or detonation is formed in the engine. The octane number of a gasoline is a measure of knocking tendency. N-heptane knocks very badly and hence its anti-knock value has been arbitrarily given 0. On the other hand, isooctane gives very little knocking, so its anti-knock value has been given as 100. Thus, if a sample of petrol gives as much of knocking as a mixture of 95 parts of isooctane and 5 parts of N-heptane, then its octane number is taken as 95. Octane number can be improved by different methods. Tetraethyl lead, TEL, is the most common anti-knocking agent added to improve octane number. Nowadays, octane number is improved by adding alkylates to gasoline. Octane numbers for gasoline, which is used in automobiles, varies. The higher performance car require gasoline with a higher octane rating. The fuel with higher octane rating prevents knocking in high-performance cars. Whereas an average car is built to run on gasoline with an 87 octane number will get the same mileage but will face knocking. Two common methods of rating gasoline and other spark ignition engine fuels are the motor method and the research method. These give the motor octane number MON and the research octane number RON. Research octane number method measures anti-knock performance under relatively mild operating conditions. The engine is run at mild load and low speed. Motor octane number method measures anti-knock performance under relatively severe operating conditions. The engine is run at severe load and high speed. Fuel sensitivity. The difference in octane number between the research method and the motor method octane numbers is known as the fuel sensitivity. Thus, fuel sensitivity Fs equals RON minus MON. Generally, fuel sensitivity ranges from 0 to 10. It measures knock characteristics of a fuel when condition of operation changes. Fuel sensitivity shows how a fuel behaves when engine's working condition changes. A low fuel sensitivity number usually means that knock characteristics of that fuel are insensitive to engine geometry. The average of two octane number rating methods RON and MON is known as anti-knock index. Thus, anti-knock index equals RON plus MON by 2. Modern way to determine octane number. When fuels of different grades are produced, it is customary to have them tested for quality in typical test motor engines using that fuel. This method is time-consuming and expensive. So, it has been replaced by more modern NIR spectroscopy. Based on a previous calibration, the octane number of the fuel is read out on the digital meter. Properties of fuel mixed with gasoline. If the alkane chain is short, then the octane number is high. However, the volatility of the hydrocarbon increases with a decrease in the chain length. The shorter alkane chains have to be mixed in petrol to lower their volatility and increase the octane number of the petrol. If the alkane is more branched, then the octane number will be higher. Cyclic compounds have higher octane number than straight chain compounds. Cetane number is a relative measure of the time delay between the injection of fuel into the chamber and the start of combustion. Cetane number is the percentage of hexadecane in a mixture of hexadecane and 2-methylnaphthalene, which has the same ignition characteristics as the diesel fuel under test. We can deduce the ignition quality of a fuel through its cetane number. A fuel with good ignition quality has a high cetane number where the ignition delay period between the start of fuel injection and the onset of auto ignition is short. A higher cetane number indicating a shorter ignition delay time usually means more complete combustion of the fuel. This translates into quicker starting, quieter operation with less diesel chatter, improved fuel efficiency, a reduction of harmful emissions, less wear and tear on the starter and batteries, quicker pumping of protective lubricating fluids throughout the system. Most fuels have cetane numbers between 40 and 60. Cetane improvers are the compounds which readily decompose to give free radicals, thus enhance the rate of chain initiation in diesel combustion. Cetane improvers promote fast oxidation of fuels and thus improve their ignition characteristics. Chemical compounds such as alkyl nitrites, ether nitrates, dinitrates of polyethylene glycols, and certain peroxides are well-known cetane improvers. Observe the table for the difference between octane number and cetane number. Summary. In this lesson, you have learnt that octane number of a gasoline is the percentage of isooctane in a mixture of isooctane and N-heptane. The average of two octane number rating methods RON and MON is known as anti-knock index. Cetane number is the percentage of hexadecane in a mixture of hexadecane and 2-methylnaphthalene.